What are the chances I missed the target back there, that square thing, with 4 sandbags by 2 feet or more? How likely is that? That's the p-value. The p-value is the probability of getting a set of data or something more extreme. In this case, it would be missing by 2 feet or more. Now, missing by just 1 foot or more would be more likely because misses don't have to go as far. So that's a higher p-value. But it would be a lower p-value if my misses had to go at least 3 feet away or more, because that's less likely. So that's all the p-value is the probability of a result or something more extreme. All right, now how do we use the p-value in statistics? Let's set up 2 scenarios. Scenario 1, you walk by and see the 4 sandbags spread out about 3 feet past the target. Now you might think, wow, he was off today. Those are some bad misses. Scenario 2, you walk by, see the same misses, but also see this catapult. You might think, I guess he was using the catapult instead of throwing the sandbags today. Now, why did your reasoning change? In scenario 1, you had nothing to compare the low probability of my misses to. Now remember, the low probability is the p-value. But in scenario 2, you figured the catapult had a higher chance than me of those misses. So you concluded I did something different and used the catapult instead of my typical throw. Now in statistics, we compare the p-value to the likelihood of an alternative. In this case, we compare the p-value of my throwing the sandbags to the likelihood of the catapult causing those misses. Here's the thing though, we typically don't know the actual likelihood of the alternative. So we ask ourselves, how low does the p-value need to be for me to reject the belief that the result came from the same old way of doing things, me throwing them? Now remember, the more I miss the target by, the lower the p-value. So how much do I need to miss it by for you to think something must have changed versus me just having some bad throws? And people often use a cutoff of 5%. So they compare the p-value to 0.05. If the p-value is lower, they conclude something changed. Now 0.05 can be a decent stand-in for the probability of an alternate explanation if you have one, a good explanation. You see the catapult? Sure, 0.05 is a fine cutoff. But if you don't have a good alternate explanation, is 0.05 really low enough? Basically, if you have a good explanation, you compare the p-value to that. But without one, you're not really comparing the p-value to anything. The 0.05 doesn't mean anything. You need it to be low enough for it to think there must be some other reason. Now, I just explained the p-value without mentioning the term null hypothesis, which is typically in the definition of the p-value. And I did that because statistical language often makes things harder to understand. But if you need to know, me throwing the sandbags would be the null hypothesis. Me not throwing them would be the alternate hypothesis. Now, whether a low p-value is low enough to reject the null hypothesis really depends on the situation.